Alright, here's the clicker if you're gonna use it.
Take it away, Alston.
Okay.
So for my senior project, I built Brobot, which is the beer pong playing robot. To understand Brobot and its goals, you have to understand what beer pong is. So beer pong is a classic drinking game. It's played by two teams. You take turn taking shots on cups. It's usually sets of 10 cups. When a shot is made, a cup is removed from the game. The point of the game is to be the first team to remove all your cups. There is an interesting mechanic in beer pong, which is the focus of this project. If you make 2 shots in a row, you get another chance to take another turn. There's no limit to this rule, so the goal was to make Brobot be able to end the game in the first turn. These are some pictures of Brobots, a little bit of how it works. It works kind of like a football cannon. It spins up 2 wheels, the ball goes in the middle. On the bottom, we got a stepper motor that's responsible for panning left and right. In the middle, we got a servo that brings it up and down. And we also have another servo that loads balls into the motors. So now for some videos of it making some shots. This is a good example. It takes 3 shots at the same value. Yeah, so all these shots in it are confirmed hits. It's just really hard to get hits to repeat.
Oh,
Nice.
I'll hit cancel, otherwise it's gonna try to do a thing. Apple, why?
So now for how Brobot works. The body of Brobot is 3D printed. I can't take credit for the design. It actually comes from an open source platform called Thingiverse. Somebody else built it just as like a ping pong launcher. But what was really sweet about it though is all the parts were sized for stuff I already owned from a kit we got from Computer Architecture. Here's a wiring diagram of Brobot. Sweet. So this is the panning stepper. Takes 4 inputs because there's like 4 little magnets inside. And I'll get more detail on that later. This is the tilt servo that's responsible for tilting Brobot up and down. This is the load servo, which is different from this one because this is a 360-degree servo, where this one's a 180-degree. And then this is the motors that are in charge of shooting Brobot. An interesting thing to note is that I have 2 of the wires reversed. So there's like a green touching a yellow and a yellow touching a green. That's important because you want the motors to spin in opposite directions to be able to shoot. Another thing to note is that pins 5, 6, and 3 are all pulse width modulation pins, which is important for how each of these 3 components work. The continuous servo, the 180-degree servo, and then this, which is in charge of motor speed. So I guess to go in a little more detail, how this one's working is if you want to think of it like stepping on the gas 100%, you'd be going 100%. But if you step on the gas 100% for a second, take your foot off for a second, on a second, off a second, you'd be going like 50%. So that's the main idea for how this one uses speed control. This one uses pulse width modulation for its position. So it goes to where you tell it depending on the value. This, I didn't know how 360-degree servos were. This was a real pain because I thought they worked a lot like normal servos, but they're kind of more speed control. And to get the specific amount of distance you want to rotate, it's based on like time delays. So for the software side, Brobot's pretty simple. It uses C++, that's Arduino's language, and then some methods I wrote that are just in charge of controlling all the components. We can pan clockwise, we can pan counterclockwise, we can tilt it, we can load it. There's a method for motor speed and then switch motor. Pretty much all of them take int values, just as like how to position them. And switch motor is a helper method of motor speed. You can't turn on the motors at really low voltages. I guess it's just too much for it to start up. So switch motors there just kind of give it a little burst so that it can get up to speed. And then there's a delay so you know it's actually running at the speed you want it to. So as you guys can tell, Brobot's still really far from playing the perfect game. The major problems I'm having with it are mostly design problems. So minimum motor speed is way too high. And as a result, I'm forced to take a really flat shooting arc, which just makes shots really hard to make. I have a video. This is just an example of it getting stuck. I don't know if you guys could hear, but it makes like a pretty loud thud. I think the problem with the design,
Oh, yeah. I don't know why that's turned on, sorry.
yeah, but I think the problem with that is just that it's way too tight to get the balls through. So it just adds a lot of resistance. I guess, yeah. So for pulse width on the Arduino, it takes values from 0 to 255. The minimum launch speed value is like 160. So a lot of my range is cut out for control. An example of the minimum angle being way too high. So the tilt servo is physically able to go lower, but you get this problem there with it actually scraping on the bottom of Brobot. So the minimum value you can shoot it at and the like highest angle shoots off the back of the table. I thought Brobot was not going to be very good at shooting, but like max speed, it could go from the front to the back of the group. Like it's really strong, like too strong. This is just kind of to provide some more detail about why low arcing shots are hard to make, because you pretty much only have a ping pong ball sized target on the back of the cup, where if you get a high arc, you pretty much get to use the whole like circle as a target. So problems and solutions. I was having a lot of trouble moving my stepper smoothly. Originally, I coded it to use one-phase full stepping. It was just a set of 4 values that represent what each pin is going to be written to, and it had 4 values within that. So the problem with that is that it doesn't add more torque to do this other version, but it was really jumpy and not smooth. So I switched to 1-2-phase half stepping, which is just kind of like a handoff in between, so it really smooths it out. And that one just used set of 4 values, but 8 of them instead. So what I would do differently is mostly design changes. I think the workaround should be pretty simple. I would like to make the arm holding up the robot taller so that it could get like level with the table, if not a little below. Another thing I'd like to change is I'd like to make the shooting wheels out to the sides farther so that it wouldn't run into the problems of, a minimum shooting speed. And I'd like to say thank you to my advisor, Kyle, and the rest of the faculty.
Who's got questions for Alston? Yeah.
How do you aim?
So I aim.
Yeah.
So the aiming is all manual. You're just testing values. The original scope of the project, I wanted to use distance measurement. Ultrasonic sensors aren't precise enough. And I tried using infrared sensors, but the max distance is like 80 centimeters, which isn't even the first cup. So
All right,
The aiming's just trial and error.
Brett, did you have a question? Yeah, sure.
Have you considered checking the bias of your DC motors?
No.
Because when you have the, given all things being equal, we buy these things online for $1. And we found that a lot of the DC motors, you send them both 160, I think you said. And one's going actually a little faster than the other. And that might have been why the ball was clinging to the inside of the cup and spinning so much, which could have also affected the aim and the result and the and. So just a thought.
Sweet, sweet. Any other questions? Yeah, Lucy.
Have you tested this out with a real game yet?
No, Brobot's not good enough, so it'd have to drink a lot.
Yeah, Elise.
Can it adjust for like different cups that are in like different ranges, or do you have to simply like put it so that it goes for the certain like row cups?
Yeah, so right now it's just running 3 different strips because it can only hold 3 balls at a time. It's broken up in like sets of 3. So there's one for first 3 cups, middle 3 cups, back 3 cups.
Yeah, Will.
Solve the arch, like, could you like think of like when you throw the ball, like you're a bit higher than the table? Like, what if you had built like a platform maybe
That's
to, I don't know, just an idea.
yeah, no, that's actually a really good point.
Maybe could have helped.
Yeah, Sean.
Did you ever think of using cameras as a way to track like where the positions are? Do you think that'd be cheating because it knows exactly where to aim?
No, I actually considered that. I just had never like touched that subject before, so I was a little scared it would be out of the scope.
Yeah, it's a lot.
I have a question. So, okay. In beer pong, do you have to throw underhanded? Is that one of the rules?
Whatever you want.
Oh, that's not one of the rules. Okay. Just curious. Well, I wonder, like, like the way it's shooting, is it more like an overhanded or an underhanded throw? But I guess that doesn't matter. So it's shooting them really hard. Is it like, does it ever like dent the balls or damage the balls at all?
Oh, so at first I was pretty convinced that like cheaper ping pong balls worked better because they like dent in more, but I was getting more problems with like one side would dent more than the other and like start to bank shots. But I'm using 1-star balls if anyone's wondering. 3 is a little too much.
Sweet. All right, let's thank Austin again.
Looking for a different